Hi, I'm an old guy and I do maths, and we have an anti-differential on our hands today. And it pays to have a really good look at this and consider how it got into this form. So, to me, this looks like it is the result of some work using the chain rule, and that this expression here was raised to a power of maybe 3 over 2 because we have we have this as a power of a half. So just let me explain what I'm talking about here. This thing here was probably something like that. Something like that. We're yet to see properly. But it always pays to have a think about where these things come from. So if we were to apply the chain rule, this would become u. We take the differential of that, which would be 2x, and I'll come to why that is not 2x in a moment. And then we would differentiate the whole thing, and this power up here would wind up as a half, hence we have this. Now, this is probably what this should be, but there is some form of dilation factor in front of this, or something like that. I don't know. But what I'm going to do, just to make my life a little easier, is I'm going to rewrite this as 2x, because that's the differential of this, x squared plus 1, and I'm just going to pop a half out the front here. So this half has the effect of making this x, so nothing's changed, it's just something written in a slightly different way. Now, again, when we're considering where this came from and how we got to here, this is the differential of this expression in here. And so when we, for want of a better term, try to put this back in its box, try to anti-differentiate it, this effectively disappears. And we are concerned with this. Now, this expression in here would have been u, as I said, when we were dealing with the chain rule. So what we really need to do, so we'll make this expression u. So u is equal to x squared plus 1. And so this is what we get when we set about trying to anti-differentiate this thing. Okay, so what is our next step? Well, we have 1/2 u to the half du will be u3 on 2 over 3 on 2, which looks a bit of a mess, but we can sort that out pretty swiftly. Now let's pop this back into our calculations. So we have 1/2, where is it? X squared plus 1 to the 3 on 2 over 3 on 2. Okay, now let's tidy this up. Oh, by the way, and this is something I always do, don't forget that. Okay, now some tidying up. Now, I haven't written this entirely clearly, so this can be written like this: 1/2 x squared plus 1 to the 3 on 2 over 3 on 2. So this is 1 times this. Don't forget the c. I keep doing that. It's a really bad habit of mine. 1 times this is our top line. 2 times 3 on 2 is 3. So our answer is x squared plus 1 to the power of 3 on 2 plus c. 2 times 3 on 2 is 3. That's our answer. That is the anti-differential of x into the square root of x squared plus 1. Now I hope you followed that. I think it's really important when you start looking at an anti-differential to try and work out how it got to where it was, where it started life at. I certainly found that helpful when I came to dealing with this. Anyway, that's what we started out with. That is our answer, and most of what you can see here is the reason for it. Thank you very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.